So we've talked a lot about different things in this course so far, and now we're going to try and spread out a couple of different ideas into one unit. And what we're going to talk about in this unit is the idea of a polynomial and a lot of things that you can do with polynomials. Now we're going to be very specific with them in this first one because we're going to be talking about specifically quadratics. Now in this first part of the unit, which is chapter 3, we're going to talk about everything that can be done with polynomials. And to start with, we're going to deal with particularly a specific type of polynomial, and that's a quadratic. So to start with, we're going to talk about what exactly a quadratic is. A quadratic is just a degree 2 polynomial. And the term that you're used to seeing is parabola. And what we're going to do is we're going to talk about how the graphs of these look and how you can compare these with other parabolas, how you identify specific things about parabolas, and how you look at a parabola and know specific things about it. So to start with, I just want to make sure that we're aware that a parabola, the general form for a parabola looks like this. That's the general form of a parabola, and what we're going to do is we're going to look at how a parabola looks when you change specific things about it. So it says compare the graphs of y equals x squared and y equals 1/3 x squared. So what I'm going to do, and then I'm going to compare it with y equals 2x squared. So I'm going to start with y equals x squared, and I'll see what it looks like. So I'm going to start with a set of points and see what happens. So if I pick 0 and I square that, that's the easiest one to square because 0 squared is just 0. So I'm going to put a dot there. Now I'm going to square 1, and 1 is fairly easy to square as well. That's 1, so I'm going to put a dot there. And usually when you graph lines, that's all you needed because 2 points to find a line. Well, we don't have a line here. We have something different. So I'm going to go one further, and I'm going to square 2. And I get 4. Now notice that that is not the same linear pattern that this is. And again, it's because it's not a line. If I went one further at 3, I would get 9. If I went one further out, I would go all the way up to here. And again, that's not the same pattern. So this point is 3, 9. Now another thing that's interesting about a parabola is if I take -1 and square it, I get the exact same thing as if I took 1 and I squared it. The exact same thing would happen if I took -2. So there's a couple of things that we need to be aware of. First of all, there appears to be this symmetry about this graph. And that's going to be true of all parabolas. All parabolas are going to have this symmetry about them. Okay? And this one happens to have an axis of symmetry with the y-axis. This is what's called the axis of symmetry. Okay, so it has an axis of symmetry. Another thing that's interesting about it is the fact that it doesn't go in one direction anymore. It goes and it goes up, comes back down, and then goes back up again. So what we need to do is we need to compare this with a different graph. So I'm going to now take these exact same values and I am going to now take them and times them by a half because it's asking me specifically for 1/3. So I'm going to take it and times it by 1/3. So I'm going to take and times everything by 1/3. Now I have all these numbers, so I'm just going to take and multiply them all by 1/3. So I have 4/3, 1/3, 0, 1/3, and 4/3. So I have all those numbers, so I'm just going to graph them. 0, 1/3, 4/3, 0, 1/3, 4/3. If I go one more out, it's going to be at 3. Now notice again, these still have these symmetric properties about them, but if you look at this and compare the two, you can tell that this curve here tends to be a little less steep than the other one. So this one is less steep. And we call this a vertical compression. So it's compressed vertically, or it's shrunk. Okay? So that 1/3 made this graph, or this curve, smaller. So it made the curve smaller. Now we're going to look at something a little bit different. Now we're going to take and we're going to multiply every x or y coordinate by 2. So we have our x coordinates. Now we're going to multiply them all by 2. Well, this originally was 4, so now it becomes 8. This originally was 1, this becomes 2. This originally was 0, it still is 0. These are now 2 and 8. So I'm going to put a 2 here, 8. This is a 2. This is also an 8. If I went one further, it'd be 16. So if I connect these, notice that this curve is a little steeper, or it's vertically stretched. So we took this graph and we vertically stretched it. We made it bigger because of the number in front. Since it's a whole number bigger than 1, we stretched it. When it was less than 1, we shrunk it. Now, if this number was negative, if this a was negative, it would be a reflection. And across the x-axis. So that is what happens, or how you look at graphs and compare them. So I'm looking at the next page, and we're asking basically to do the exact same thing, but to compare these with this original graph. So just make sure that you know that the original graph is just a parabola, and this number here in front has an effect on how it looks vertically. It could be vertically stretched or compressed. But the way I would start it is you've got your base values at -2, -1, 0, 1, and 2. I would go off of those and make some answers from those with each one of these and see what happens. Now I jumped ahead to look at the next example, and the next example is going to have some notation that we have to be aware of, specifically how you deal with a parabola if you don't necessarily know how to graph something when there's a graph not in front of you. Okay? The notation, first of all, is this vertex, and if you have a parabola that looks like a curve, again, this is what the general shape of a parabola looks like. There is a specific point where everything seems to be mirrored across. That right there is called the vertex. And there's a way to find this vertex. Okay? If you have something that looks like this. Okay, and the way you do that is this way. Now you might say, what does that even mean? I don't even know what that means. That looks like complete gibberish to me. Well, we have a and b here. Those are just coefficients, or numbers in front of variables. If we can find that, it'll be very straightforward on how you find a vertex. Okay? So what I need to do is I need to find out what a and b are. In this case, a is equal to 8. B is equal to a positive 2. Now from this, if I put in negative b over 2a, or negative, sorry I have these backwards, a is 2, b is 8. If I put in negative 8 over 2 times 2, which is 4, I get negative 2. Now you might say, what's the point in finding the vertex? Well, I will tell you why it's very important. The vertex is where everything is centered around. So if I plug in negative 2, okay, what this means is that you plug in to find y. So I'm going to plug this in to find out what y is. So 2 times negative 2 squared plus 8 times negative 2 plus 7. Okay, so 2 times negative 2 squared, or 2 times 4, that's 8, minus 16 plus 7. That's going to be a negative 1. And this will plug in for your y answer. Okay, so I plugged in, I found my y value. So in terms of my parabola, my vertex is at the point 2 comma negative 1. So that means everything is centered at this point. It means if I pick 0, which is fairly quick to find out, because if I plug in 0, this all cancels out, this all cancels out, I'm left with 7. So I can go all the way up to 7. That means that at negative 4, which is on the exact opposite side of the vertex, I should also get 7. So there's a property of symmetry about this vertex. Okay? And this is called, they say axis, this is called the axis of symmetry. So this is called the axis of symmetry. Right? So now I'm just going to plug in one more point. Plug in negative 1. If I plug in negative 1 to this whole equation, I get 2 times negative 1 squared, or 1, plus 8 times negative 1, or a negative 8, plus 7. So I get a positive 1. that means the other side also will be a positive 1 as well. So I have